Okay, let's look at the solution of this paper. Question 1. fx is the sum of two parts. One part varies as square of x minus 3 and the other part is a constant. And suppose f1 is 15 and f negative 1 is 63. A. Find fx. B. Let g1 be a graph of y equals fx. g1 is shift, that means move 3 units to the right to become the graph g2. Find x-intercepts and y-intercept of g2 respectively. Okay, for part A, it is a very standard question about the variation. So A, fx can be written as a first constant A multiply a square of x minus 3. So x minus 3 bracket square, that's the first constant A. And the other part is a constant, so plus another constant B. Okay? So that's the format of fx. A times bracket x minus 3 all square plus B. And next, you know that f1 equals 15. And f1 that means you substitute x equals 1. So this will be 15. And f negative 1, that means x is replaced by negative 1, and which is 63. So you get two equations with two unknowns. The first one will be a times negative 2 bracket square, that is 4a, plus single b, that is 15. And the second one, that is a times negative 1 minus 3, here that is negative 4. But bracket square, so that is positive 16, plus b equals 63. You can do the subtraction of these two equations, then you will get 4 minus 16, negative 12, b minus b cancel, 15 minus 63, that is negative 48. And therefore a, that is 4. When you get a equals to 4, then you can find b. B is negative 1. And therefore, write down the final answer. Fx can be written as 4 times bracket x minus 3 all square minus 1. We call this one as a vertex form. Okay? So that's the end of part A. So go to part B. Originally, you can consider the graph y equals fx. That means g1. Okay? So you know that the graph y equals fx with the vertex 3, negative 1, because it is the vertex form. So that is the vertex of g1. And of course, you can sketch the g1 at the very beginning. When you substitute x equals to 0, then you can find the corresponding value of y. That means f0, which is 4 times negative 3 bracket square, that's 9. So 4 times 9, that's 36, and then minus 1. So you get that is 35. And you know the graph will cut the y-axis at 35, and the vertex is 3, negative 1. So you know that that is g1. And now this graph g1 is shift 3 units to the right to become g2. So the vertex will shift 3 units to here, becomes 3 plus 3, that's 6, negative 1. Alright? As you can see that if you shift the graph from g1 to g2, okay, move 3 units to the right, then you will see that all the points with the x coordinate plus 3, okay, x coordinate plus 3. But how about the function? g1, that is the function y equals fx. Alright? And we know that when x equals 3, y will equals -1. That's the relation we have, okay? f3 equals -1, okay? But how about G2? That is y equals function of something, right? But the key point is you want to keep the y coordinate is also -1 here, okay? But your input is 6. So what can we do? If you want to input x equals to 6 and the output of y is -1, so here inside the bracket you should minus 6 by 3. So here the graph of G2, that is f bracket x minus 3, to cancel the effect of this 6, okay? Because you want to always keep f3 equals -1. So the graph of G2, y equals f x minus 3 actually. And what is the meaning of x minus 3? That means for all x here, it replaced by x minus 3 here. So you can see originally that's 6, x to the x. Now I want to replace this one by x minus 3. So that is x minus 3, and then use this minus 3 again, all square minus 1. So y equals 4 bracket x minus 6 all square minus 1. Okay? So that's the way you find the graph of G2. So how do we find x-intercept? You can put y equal to 0, 4 bracket x minus 6 bracket square minus 1 equal to 0. X minus 6 all square equals 1 over 4. When you take the square root, x minus 6 equals 1 over 2. Or x minus 6 equals -1 over 2, okay? So you can find x, that is 13 over 2, or x, that is 11 over 2. These are the x-intercepts. Therefore, x-intercepts are 13 over 2, 11 over 2. How about the y-intercept? You substitute x equal to 0. So y equals 4 times 0 minus 6 all square minus 1. -6 bracket square, there's 36. And you get this one, that is 143. Therefore, the y-intercept is 143. So that's the end of part B. And again, you can see very carefully how do we obtain the equation of graph G2 from G1. If the graph is moved 3 units to the right, then the position of x should minus 3. Okay? So that's the end of question number 1. And then move to question number 2. So question number 2 is about the quadratic inequality or a quadratic equation. Consider a quadratic equation. X is a constant. A. Prove that the quadratic equation has 2 distinct real roots. When you see the root nature of the quadratic equation, it usually is related to delta. For 2 distinct real roots, that means you need to prove, the keyword is prove. Okay? Delta is greater than 0. No equal to, but greater than. Because the question wants you to prove that these 2 roots are real and distinct. That means different. Okay? So A. We consider the discriminant. That is b squared minus 4ac. In here, okay, let's do some revision. For the a, that means coefficient of x squared, that's 1. B, that means coefficient of x, so that's x plus 1, okay. And c, that means the constant term of the quadratic equation. So that's the delta b squared minus 4ac. And how do we simplify this? Just remove the bracket, and you will find that the discriminant can be written as x squared minus 2x plus 1 plus 4. So luckily you will find that the first three terms can operate the perfect computing square. So the discriminant can be written as h minus 1 bracket square plus 4. And pay attention here. For the first expression here, h minus 1 bracket square, it is non-negative. Because it's a square, it will not be negative. And now you add 4 to it, so it must be positive for all values of h. Okay? So you can make the conclusion, no matter what is the value of h, this equation must have two distinct roots. Alright, and then go to part B. Now, given that alpha and beta, they told you that alpha is greater than beta, are the roots of the quadratic equation, okay, the original one, such that alpha minus 1 times beta minus 1 greater than 0, so find the range of h. The question told you that alpha and beta are the roots of this equation, so you can apply sum of root and product of root. Alpha plus beta, that's equal to negative bracket h plus 1 over 1, so that is negative h plus 1, sum of root. And product of root, alpha times beta, that is so-called c over a, h minus 1 over 1, so h minus 1. And now, starting from the inequality, alpha minus 1 times beta minus 1 greater than 0, therefore alpha times beta minus alpha minus beta plus 1 greater than 0. And next, alpha times beta minus bracket alpha plus beta plus 1 greater than 0. So you can substitute this alpha times beta and alpha plus beta by h, okay? So h minus 1 plus h plus 1 plus 1 greater than 0. And you can solve the inequality of h. So h is greater than negative 1 over 2. So that's finished B1. Okay, finish B1. And B2, in addition, alpha minus beta is less than or equal to square root of h. So find all possible integral values of h. And I just want integer, okay? I just want integer. So what can we do? Part 2. As we know that alpha minus beta less than or equal to square root of 8, and of course alpha is greater than beta, so it is positive, okay? We don't need to write this. And now we take square of it. Alpha minus beta bracket square will less than or equal to 8. So how do we simplify this one? We can simplify it as alpha plus beta all square minus 4 alpha beta directly. Some of you may wonder, okay, why we can change to this one? Okay, let me show you. We start from alpha plus beta bracket square minus 4 alpha beta. When you try to expand this, become alpha square plus 2 alpha beta plus beta square minus 4 alpha beta. Okay? Plus 2 alpha beta minus 4 alpha beta, so that is minus 2 alpha beta. And alpha square plus beta square right in these two positions. So you can see that this one, alpha square minus 2 alpha beta plus beta square, can be written as alpha minus beta all square. So you can do it in this way, or you can go back to in this way. That's mean alpha minus beta bracket square can be changed into this one. Alpha plus beta bracket square minus 4 alpha beta. So go to here, alpha plus beta bracket square, that is h plus 1 bracket square. And then alpha times beta, that is h minus 1. less than or equal to 8. Now simplify it. H squared plus 2h plus 1 minus 4h plus 4 minus 8 less than or equal to 0. So h squared minus 2h plus 1 plus 4 minus 8, that's minus 3. So you can factorize these expressions, okay? That's become h minus 3 and then h plus 1 less than or equal to 0. Some of you may try to use calculator to plug in 1, -2, -3 directly, and you can apply the quadratic formula in the calculator to find two answers. One of them is 3 and other one is -1. But you need to draw some graph in your rough work like this, okay? Not just write down the answer directly. So you need to draw the quadratic curve like this. There's a variable h. Now you want the value the less than 0. That means below the axis, below the horizontal axis. So it should be something in between -1 to 3, okay, here. So your final answer should write in this way. H is lie between -1 to 3, okay? But don't forget, go back to B1. We have the original condition that the h is at least greater than -1/2. So that means there are two inequalities you need to consider. The first inequality is h should be greater than 0.5. Okay? Another inequality is h should lie between -1 up to 3. Okay? We use the solid circle because -1 and 3 should be included. You need to satisfy both of the condition. Okay? So we will consider the overlap region. First one, h should greater than -0.5. Second, h should lie between -1 to 3. So the overlap region is something in between -0.5 up to 3. And hence the final answer should be -1/2 less than h and then less than or equal to 3. That is your final answer. Hence h can be 0, 1, 2, and 3. Okay, the possible integral solution. So that's the end of B2 and also the end of question 2. So let's go to question number 3. For question number 3, a solid right circular cone is divided into 3 parts by 2 planes which are parallel to each base. So what does that mean? You can try to draw a big cone like this. It is cut into 3 parts by 2 planes parallel to each base. The height of 3 parts are equal. Okay, so the height of 3 parts are equal. So this means there's h, there's h, there's h. The volume of the middle part is 700 pi cm cube. Now I want to find the volume of the original cone. That's in the big cone, original cone. Okay, let's draw the picture and assign the name of these different kinds of the solid. We call it as A, that's B, that's C. Okay? So in part A, we know that the height of the solid A equals to the height of solid B equals the height of solid C. So we can write it this way. Height of A to height of A plus B to height of A plus B plus C equals 1 to 2 to 3. Why we need to present such a strange way? Because the solid A plus B and the solid A plus B plus C, these three solids are three similar cones. Okay, these three solids are three similar cones. So we need to find their length ratio, that is 1 to 2 to 3. Therefore, the volume of A to volume of A plus B to volume of A plus B plus C will be the cube of the length ratio. So the 1 cube, 2 cube, 3 cube. That means 1 to 8 to 27. But here, pay attention. A occupy 1 part. A plus B occupy 8 part. That means B occupies 7 part. Okay. Also, A plus B plus C occupy 27 part. And A plus B occupy 8, so C occupy 19 part. So finally, volume of A to volume of B to volume of C, actually that is 1 to 7 to 19. And now I want to find the whole cone volume. So volume of the original cone, it is 700 pi. That is the volume of B divided by 7 part, because it occupies 7 part, right? And the whole cone occupy 1 plus 7 plus 19. That means 27. Okay? Unit cm cube. So final answer, 2,700 pi cm cube. That's the end of part A. B, the height of the original solid is 36 cm. So we can find the base radius of the original cone, right? 1 over 3 times pi r squared times 36, that is 2,700 pi. And hence r squared, that is 225. R, that is 15, because you are finding the length, the base radius, okay? So we use the concept of similar figure again. The curved surface area ratio of similar figure will equals to the square of the length ratio of the similar figure. So surface area of A to surface area of A plus B. Remember, we always start with these three solids, A plus B, A plus B plus C. These three cones, okay? These three cones, okay? To surface area of A plus B plus C, that will equals to the square of the length ratio. That is 1 to 4 to 9, okay? So therefore, the surface area of A to surface area of B to surface area of C would be 1 to 3 to 5. Why? Because A plus B occupy 4 parts, so B only occupy 3. And A plus B plus C occupy 9 parts. A plus B occupy 4 already, so C would just have 5 parts only. Okay? So the surface area of the middle one, that would be, you find the curved surface area of the whole cone, pi r l. 15 square plus 36 square, square root, that's the curved surface area of the whole cone, divided by 9, and then multiply with this 3 cm squared. Final answer, that is 15 square plus 36 square, square root, that's 39, the slant height is 39, and then multiply with 15 times 3 over 9, that is 195 pi, but you need to press pi. So answer 613 cm squared. Correct to 3 significant figures. And that's the end of question number 3. Now go to question number 4. For question number 4, that is the concept about the completing square and the transformation of the coordinate. So let gx be this function, and k is a non-zero real constant. Gx, that is 4x squared plus 24kx plus 38k squared plus 2. K is a constant. Gx here, x is a variable. Use the method of completing the square expressed in terms of k, the coordinates of the vertex of the graph of this one. Okay, how do we read this one? The graph of this one has the vertex, right? It has the coordinate we want to find, but the answer should be in terms of k. How do we find this? Use completing square. Okay, so you read the sentence backward, okay, and you will know what you need to do. A, gx, that is 4x squared plus 24kx plus 38k squared plus 2. And here we need to take out the number of the coefficient of x squared, 4. For the first two terms, take out 4, okay? So the 4 bracket x squared plus 6kx, and then plus something and minus something inside the bracket. Why? Because you want to add a term to make it become the perfect square. So what we can do, we should consider 6k divided by 2 first, and then bracket square, that is 9k squared. That means you need to plus 9k all square, and then minus 9k all square inside the bracket. Inside the bracket. You cannot just originally add 9k square, right? You need to minus 9k square to cancel the effect. So the next step you will do is multiply this 4 to this negative 9k squared. You keep the first 3 terms inside the bracket. So the negative 36k squared plus 38k squared plus 2, right? And inside these 3 terms, okay, so it is the perfect square, x plus 3k all square, and then plus 2k squared plus 2. Therefore, it is a standard format of vertex form, and the vertex is here. When you see x plus something, the x coordinate of the vertex will be negative, okay, 3k. And the y coordinates of the vertex will just copy the constant term at the end after you change it into the vertex form. Remember, when you need to find the vertex, one of the usual methods is using the method of completing the square, okay? Make it the function as the perfect square or at the vertex form, and then write down the vertex coordinate. B. On the same rectangular coordinate system, denote the vertex of the graph of y equals fx, gx, and the vertex of the graph of y equals 7g minus x by A and B, respectively. Oh, very long statement. There are two vertices. First one, vertex of the graph of this one. We call it as A. Actually, that's A, right? That's we get. This point is A. And another vertex of this graph, we call it as B. Okay? So you can write down point A, actually that is negative 3k, 2k squared plus 2. But how about B? You need to write down B first, and then otherwise you cannot, or you will find it very difficult to do the following part. Point B, that is the vertex of this graph of y equals 7g minus x, negative x. What does that mean? That means this gx, or the graph y equals gx, is reflect along y-axis become y equals g negative x. That's the first transformation. Okay? From gx, how do we change to g negative x? Okay, in the coordinate system, that is the reflection of the graph y equals gx along the y-axis. That's the first step. Then, stretch y equals g negative x. Okay, we scratch this one 7 times along y-axis. Okay, make it longer, thinner. Therefore, the vertex here that become, of course, negative 3k. It has no any effect of the x coordinate of any point in the graph. It just first of all, it should be positive. It should be positive, okay, because it changed the x coordinate, okay, from positive to negative, or it multiplied with the negative sign here. So it is a positive 3k now. And then here, multiply 7 times, that's become 7 times 2k squared plus 2 with the bracket. So there's 14k squared plus 14k. That is the vertex B. Okay? Now let M be a point lying on AB such that the area of OBM is the double the area of triangle OAM. O is the origin. So let's see what's happened. Okay, we may draw some figure like this. A, B, okay, that's point O, and that is point M. M is here, okay. The area of triangle OBM is twice, or is double to the area of triangle OAM. O is the origin. The key point is, if we consider MB as the base, then that will be the height of the triangle OBM. But at the same time, this is also the height of triangle OAM. Therefore, you can see in the graph, triangle OAM and triangle OBM, they share the same height. And that means their area ratio is the same as their length ratio. Okay, so you could present in this way. Note that because OBM, this area of triangle, is twice or double to the area of triangle OAM. So MB is double to AM. And therefore AM to BM, that is 1 to 2. So you can find the coordinate of M using point of division. Okay, point A, negative 3k, 2k squared plus 2. Point B, 3k, 14k squared plus 14. So negative 3k times 2 plus 3k times 1 over 3. And the y coordinate, that is 2k squared plus 2 times 2 plus 14k squared plus 14. And then over 3 again. So you can see that it can be simplified as negative 6k plus 3k, that is negative 3k, over by 3, so negative k. And here, 4k squared plus 16k squared, that is 18k squared. 2 times 2, that's 4. 4 times 14, 18. And therefore, you can further simplify this one. That's negative k, comma, 6k squared plus 6. And that is the coordinate of m. So that's the end of question number 4. And finally, we go to question number 5. That is about a trigonometry question in 3 dimensions. In the right tetrahedron VABC, face ABC is an equilateral triangle and VA equals VB equals VC. It's known that triangle ABC is a AB, that's 12 times square root 3, and the angle between the edge VA and the face ABC, that is 60 degrees. So we need to find the length of VA. First of all, we draw the tetrahedron first. Okay, that's V. I'll draw it as A, B, and C. All right. So what is the meaning of right tetrahedron? That means if we project V to ABC, it lies on circumcenter. Okay, then you may wonder, if I map V to the horizontal ground, okay, we call this point as O. O would be the circumcenter of triangle ABC. So let's see anything special about this triangle ABC and O. Well, A is here, B, C, and O is here. As you know that this is a equilateral triangle. So very lucky, all 4 points are lying on the same point. So you can say this point would be, in this case, not just only the circumcenter, but also the centroid, also the orthocenter, also the incenter. So if we consider it as a centroid, so this one will cut it AC into 2 equal parts. That is 6 root 3, 6 root 3. And also, if you consider O is the in center, then OA will cut the angle ABC into 2 equal parts. So that is 30 degrees. Okay? So you can find the length of OA. You can find the length of OA. And one more condition. The angle between the edge VA to the face ABC is 60 degrees. What does that mean? That means if we project V on the face ABC, angle VAO would be 60 degrees. That's the key stuff. Okay? Therefore, you can first find OA and then find VA. You should draw this graph in your solution. Okay, in triangle ABC, this 6 root 3 over OA, but it's a right angle, okay, over OA, that is equals to cosine 30 degrees. Then you can find 6 root 3 over cosine 30 degrees, that is OA. And hence you can find OA, that is 12. And now go back to this figure. OA is 12, so 12 over VA, that is cosine 60 degree, and 12 over cosine 60 degree, that is VA, so VA, that is 24. Okay, so finish. Go to part B. Part B, find the volume of this tetrahedron. That's quite straightforward because you can find OV now. That's the height of the tetrahedron by using Pythagoras theorem. Also, there's 60 degree, right? AC 12 root 3, BC 12 root 3. You can find the area of triangle ABC. So, area of triangle ABC, that is 1 over 2 times 12 root 3 times 12 root 3 times sine 60 degree. In here, just pay attention, that is sine 60 degree, that is actually root 3 over 2. Root 3 over 2. For the first three number multiplied together, that's quite straightforward. 1 over 2 times 12 root 3 times 12 root 3, that is 216 times square root 3 over 2, that is 108 times root 3. That is the area of triangle ABC. And next, the length of VO, you can use Pythagoras theorem to tackle this. VO, that is square root of 24 square minus 12 square. Use the calculator to plug in. That is square root 432. And of course, you can simplify it. Root 3. Why? Because 432, it can be written as 144 times 3. Okay, so take square root, you get 12 root 3. And hence, the volume that could be written as 1 over 3 times base area times the height, that's VO, unit cm3. So you can get the final answer. This one. And go to part C. We need to find the angle between VAB and the face VAC. So let me draw another graph, okay, because A is here, we cannot see the angle very clearly. Okay, now for part C, now I assume V at the top, A is here, okay. Something like that. VAB and VAC. As we found, VA that is 24, VB, VC also 24, and the AB 12 root 3. Okay. So how do we define the angle? Okay. The way to define the angle is, first of all, find the common line of these two faces, that is VA. And next, for each face, that means VAB and VAC, you draw a perpendicular line to the common line VA. So starting from B, we draw a perpendicular line here. We call this as point K. And also, we draw the perpendicular line from C to VA. And you will see that since these two triangles are congruent, so when you draw the perpendicular line from C to VA, it will meet with K. because they are congruent, also they are isosceles triangle. Okay, so they will meet at the same point. And the key point is we should find the length of BK and CK. So the required angle, okay, go back to the figure here, it should be BKC. Our target is find angle BKC. Okay. So how do we find the length of BK? Actually, it should be quite straightforward. That is 24. We can do it in this way. Try to draw a line like this. Draw the height. And here, this side will be 6√3. Okay? So we can find the height of this isosceles triangle. That should be 24 square minus 6√3 bracket square, and then take square root. That is the length of the dotted line. And then multiply to the base 12√3 over 2. This is the area of triangle VAB. I repeat, the area of triangle VAB can be written as AB 12√3. That means multiply to the dotted line using Pythagoras theorem, that is 24 square minus 6√3 bracket square, and then take square root, and then over 2. But on the other hand, if you consider VA as the base, then you can multiply BK and then over 2. It is also talking about the area of triangle VAB. So you can see that these two values are the same, and hence we can simplify this. 12√3 times square root, that is 24 square minus bracket 6√3 all square, so square root 468 equals to 24 times BK. Alright? And you can find BK, that is 12 times √3 times square root 468, and then divided by 24. So that is 18.734994. Now you got this, and you can consider another triangle BKC. Point K, that is 18.734994. KC are also the same because these two triangles are congruent and isosceles. So you can just copy this, and then this, the length of BC, that is 12√3. We want to find this angle BKC. Okay? Again, you can see this is another isosceles triangle. Okay? And you can apply cosine rule directly. Okay? I don't mind. Okay? You can just apply cosine angle point KC equals 18 plus 7 3 square plus 18 plus 7 3 square minus 12√3 all square. Now of course you need to use all numbers to calculate. Okay, I just write down 2 digits to do decimal place, but you need to write down all of them and put it in the calculator. Quite long. Then you can find angle BKC. You can use one formula, put in all numbers to get the final answer. Okay, but for me, I want to introduce second method. Since you find that is an other isosceles triangle, right? So I draw this one. Okay, I call these two as theta respectively, and each of them will be 6√3, right? So you can do in this way. Sine theta actually equals to 6 6 times root 3 over 18.734994. So 6 root 3 divided by this answer, and then shift sign, you can find theta equals to 33.69006752 degree. But the final answer is 2 theta, right? So therefore angle BKC, that is 67.4 degree to 360. Of course, when you use the cosine formula, you will also get 67.4 degree directly, okay? Just up to you. But in here, when you see that there are some isosceles triangle here, not always apply the cosine formula. Sometimes you can draw the axis of symmetry to find the angle easily. So that's the end of this paper. Thank you.